7.4a, more equations. That's what we love, more equations. We're dealing with the quadratic form again. We're not going to be doing things with the quadratic formula in this section, but we are going to deal with quadratics. So, we've been dealing with things like 16x squared minus 8x minus 4 equals 0, and then you use the quadratic formula, or you would try to break it down into two binomials and solve that and find out what x equals, and you're going to get two answers, and we went from there. Okay, this section is it's tricky, and it's also very useful, yet it's not one of those methods that naturally comes to mind when you're solving algebraic equations. So that's the part that's a little bit frustrating, is it works great, but they don't seem to practice it enough so that when you come into problems like this, that you recognize that there is a way to do this different than the hard way. So I'm going to put this on here. And one of the things that you'll recognize is that there's a 2 here. And so therefore, we've got this quadratic equation. Another thing that you'll notice here is we have an x plus 3 and it's squared. And then we have an x plus 3 that is just got an exponent of 1. And then we don't have an x plus 3 here. So let's just try something kind of different here. Like I say, it isn't remembered a lot, but let's just say that I take the letter y, and whenever I see an x plus 3, I'm going to put a y in its place. Okay? I can do that. It's just a form of substitution. So if I do that, this part becomes y squared, because I replaced x plus 3 with y. Minus 2, x plus 3 is the same as y, minus 8 equals 0. So I didn't really do anything odd. Well, I did do something odd, but incorrect. I just said whenever I see an x plus 3, I'm going to put a y in its place. And I did that in both of those terms. Now, the key thing is, once we solve for y, then whatever y equals also equals x plus 3, and therefore we can solve for x. So anyway, if that's a little confusing, let's just give this a shot, and I'll show you what I mean. So we have this equation. One of the things we're going to do first, we're going to see if we can divide that into two binomials. If we can, great. If we cannot, we would have to use a quadratic formula. So what number multiplied together gives me negative 8, added gives me negative 2. Let's see, 4 and a 2 give me a negative 8 if one of them is negative and one of them is positive. And the one that has to be negative is the one is going to be the largest one, because we want a negative number here. So in order for this to be negative, the largest one has to be negative, so that when we add these two, we get a negative number. So negative 4 plus 2 is negative 2. Negative 4 times 2 is negative 8. So there we go. So let's go ahead and solve this. Whoops, need a pencil here. Y minus 4 equals 0, and y plus 2 equals 0. So therefore y equals 4, and y equals negative 2. So if y equals 4, then I can put a 4 in place of this y, right? Because that's what y is equal to. So let's do that. So I'm going to put a 4 in for y and say that equals x plus 3. Subtract 3 from both sides, I get x equals 1. Over here, I'm going to put negative 2 in, so negative 2 equals x plus 3. I am going to subtract 3 from both sides, and therefore I'm going to get an x equals negative 5. So notice what I did here. I took a value here and substituted y for that value, found an answer, and then substituted back so I'd get back to my original, to where I was actually finding x. So I did kind of a double substitution. I substituted for y to make this easier, and then I took my y and substituted it back into x to get the actual answer. So I end up getting x equals 1 and x equals -5. So I ended up with an x value. The y's disappeared because I substituted it back in for x. Okay. So another way of doing this, and I'm not going to do it because it's something that you're already familiar with. Let's say that you didn't remember, which I have a hard time remembering, to do that substitution method. It may be that you take this, x plus 3, well, let's just go ahead and square it. So you're going to do the FOIL method, x plus 3 times x plus 3, and you get x squared plus 6x plus 9. Minus 2x minus 6 minus 8 equals 0. So x squared, I'm going to combine these two, plus 4x, combine this, and I get minus 5 equals 0. And then I can divide this into two binomials and get x, -1, positive 5, so that I get -5 and a positive 4 when I add them together, and x equals 1 or -5. So see, I got the same answer, and I didn't do any substitutions. Okay, which, if it were me, I would be doing this method here because it's a lot simpler and a lot less confusing. But because it's the beginning of a lesson, they're going to give you a problem that's pretty easy to do. And that's why it works so well this way. There will be problems where it's pretty much impossible to do any other way except that substitution. So it's good to know that method. Okay, so for example 2, page 606, I have 4x to the 4th power plus 7x squared equals 2. Okay, this here tells me I'm going to have 4 answers. So that means I've got quite a job ahead of me. So let's see. Quadratics tell me that a good quadratic where you can factor is going to be something like that. Okay, and I'm making this up. This has nothing to do with this over here. This has a squared, this has a 1, and this doesn't have an x value at all. That's what I like. That's not what I have. So let's go ahead and rewrite this as 4x to the 4th plus 7x squared minus 2 equals 0. Get everything on the same side. Okay. And here is the clue to doing these. This makes it easier for me. If it doesn't make it easy, if it makes it confusing, ignore me. But this is what really helps me. I look at the middle variable, okay? I look at the middle variable and set that middle variable equal to y. Okay, so when I had, let's look real quick back at the first example, x plus 3 squared minus 2x plus 3 minus 8 equals 0. I didn't tell you this, but I'm telling you now, if we take that middle term, or that middle variable, and set that equal to y, then I can, what did I do? Equals y. Then whenever I see an x plus 3 in this equation, I put a y in its place and solve it. It's the same thing over here. Okay, so let's look at that, and it'll keep things from being very tricky for you, hopefully. So here we go. X squared is my variable. So I'm going to set that x squared equals y. So let's go ahead and rewrite that using y instead of x squared. So this ends up being 4y squared, because really this is x squared squared, because then you got 2 times 2 is 4. So x squared squared. So if I replace my y, or if I put in a y instead of x squared, I still have this 2 here, and that's what that 2 there is. Plus 7y minus 2 equals 0. So there's my equation. I substituted, made life so much easier. And then I'm going to go ahead and multiply 4 times negative 2. So I need to find two numbers. So 4 times negative 2. Two numbers multiplied together give you negative 8. Added give you a 7. Okay, so those numbers, let's see, what are my factors of 8? Negative 8 and 1, 8, negative 1, 4, negative 2, negative 4, 2. Okay, so those are my factors. So this one ends up being the one I want, because if I multiply those together, I get negative 8. If I add them, I get a positive 7. So let's use those. So we're going to substitute the 8 and the negative 1 for the 7 here. And this is old stuff. Remember, we did this a while back. 4y squared minus 1x plus 8. Oops, I'm sorry. It should be a y, shouldn't it? 2 y plus 8y minus 2 equals 0. Okay, and then we group. Remember this? And we look and see what we can factor out of there. We can factor out a y, and we're left with 4y minus 1. Okay, and over here we can factor out a 2, and we're left with 4y minus 1. And remember, these have to be the same in order for this to work. Put things together, the things outside the parenthesis together, and one of the things inside the parenthesis together. Okay, and we keep going. Y plus 2 equals 0, and 4y minus 1 equals 0. So when we do the math there, y equals negative 2. And when we do the math here, y equals 1/4. So that's what y equals. We don't have any y's in our original problem. So we cannot leave that way. So what we're going to do, remember up here, we said that x squared equals y. What is y equal to? Negative 2. Y is equal to 1/4. I'm going to make this a little smaller here so that, because I think it's important for you to, keep seeing all of this. I'm going to make it real small here. Okay, so y equals 1/4, and y equals negative 2. So those are our two answers. So if y is 1/4, then 1/4 is equal to x squared. Right? Because I'm just substituting y. If y equals 1/4, then I can take this 1/4 and put it in place of y and get that. If y is negative 2, I'm going to put a negative 2 there. And let's do that in blue. Okay? So now I need to solve for x. In order to do that, I'm going to take the square root of both sides. So x equals, don't forget the plus or minus, the square root of 1/4, which is 1. Because okay, let me not skip any steps. It's equal to the square root of 1 over the square root of 4. And what is the square root of 1? 1. What's the square root of 4? 2. So, oops, I'm sorry. I did that again. That needs to be an x. We're done with the y's. Okay, so x equals plus or minus 1/2. 1/2 or negative 1/2. Those are my two answers there. Now let's look at this one. Take the square root of both sides. So we have x equals plus or minus square root of negative 2. Okay, notice this negative right here. That means we automatically turn it into an I and bring it outside of the radical sign. So x then for this one equals I square root of 2 or negative I square root of 2. So notice I have 1, 2, 3, 4 answers, just like this said I would. Okay? So we are done there. So notice how weird our answers are. I mean, fractions aren't too bad, but having imaginary numbers, there's no way we could have factored this into two binomials unless we substituted x squared or y in for x squared. So remember that middle variable is what your y is going to be equal to, and then that will work all fine and dandy. Okay, let's keep going. I'm going to do this in the next video. We'll start on example 3.